Dear students, today we are going to derive equation of motion by graphical method. So first we take first equation of motion, v is equal to u plus at. This is the first equation of motion. So first of all, we have to draw the graph. This is known as velocity time graph. We represent time along x-axis and velocity along y-axis. OA represents initial velocity, CV represents final velocity, and OC represents time. And slope of this graph, this inclination along horizontal line AD represents acceleration. Now come to the point, we gather the information. This is a graph of uniform acceleration A with u as initial velocity and v as final velocity. Let the time taken is t and the distance covered is s. Distance covered is given by the area of OABC. So initial velocity is u equal to OA is equal to CD. Initial velocity OA, u equal to CD, that is u. Time is OC, that is equal to AD equal to T. Final velocity is V, CV. CB represents final velocity. This can be written as CD plus DB. CD is U, so U plus DB. So here, final velocity V, CB, CD plus DB, V, U plus DB. So we want to find acceleration now. Acceleration is the rate of change in velocity. So simply change in velocity upon time. Final velocity is CB, initial velocity is CD. So CB minus CD upon OC is equal to DB upon T. Here you can see CB is final velocity, CD is initial velocity. So CB minus CD is equal to DB, that gives the change in velocity. So V minus U. So this is C minus dB upon T. When T comes this side, AT equal to dB. So in this way, we find the value of dB. We have other way to find the value of dB. Inclination A gives the acceleration. So simply we can write here, as I have written here, slope of the graph represents the acceleration, this one, and acceleration A is given by BD upon AD. So BD upon AD, BD is BD, B and AD is T, so BD upon T when T comes this side, so AT equal to BD or BD equal to AD. So we can write these 1, 2, 3, 4 lines in place of these lines here by the definition of acceleration. So we'll reach here AT equal to DB. So in place of 1, 2, 3, we can write those 4 lines, or it depends on you. So now finally we get AT equal to DB. So from 1 and 2, we can write V equal to U plus AT. This is the first equation of motion. Now come to the second equation of motion. In the second equation of motion, we have to find the distance covered. Distance covered is given by the area of velocity time graph between velocity time graph and time axis. So velocity time graph and time axis, this gives the area covered, and this can be split into two parts, area of this rectangle and area of this triangle. As we have discussed, first we want to find the value of BD. So in case of BD, we can start from acceleration A equal to slope of the graph. So slope of the graph represents the acceleration. A equal to BD upon AD. So BD upon T. When T comes this side, AT equal to BD, so BD is equal to AT. Here, if you want to second equation of motion after first equation of motion, say, so once we find the value of AT here, we don't need to find the value of AT again here. So we can make here equation 1 or equation 3, here equation 2. So from equation 2 we can get directly. But if the question is about to derive second equation of motion, then we have to find the AT here, because we don't write all these here. So we have to start from here. So for that, we have to first find the value of AT. BD, so that is AT. Now, again I start from second equation. Okay, for second equation of motion, slope of the graph represents acceleration A. So A equal to BD upon AD. BD upon T. So BD equal to 80. Now, distance travel is given by area OABC. This can be written as area of OADC plus area of triangle ABD. So area of this rectangle OA into AD. So OA into AD, U into T. So OA into AD, U into T. Area of this triangle half into base AD, T, BD, AT. So area of the AD, T, BD, AT. Why BD, AT? Because BD equal to AT, proved above, here we have proved. So what we get? UT plus half AT square, hence S is equal to UT plus half AT square. Now, in third equation of motion, we have V square minus U square is equal to 2AS. This is the third equation of motion. Again, we have to find the area of this figure. So this is whole area. But here we apply the formula for trapezium. Area of a trapezium is half into sum of parallel sides, this side into this side, into height is OC. So in the graph, the distance travel is given by the area of trapezium OABC. OABC is trapezium because this side OA and CB are parallel. So area is given by half into sum of parallel sides into height, half into CB plus OA into height OC. So in place of CB we can write V, OA we can write U, so V plus U. In place of OC we can write T, so V plus U into T comes here, 1 into V plus U. So V plus U into T upon T. This is equation 1 if you want to find the third equation only. So, but if you want to find all the three equations, then we have to put the number of equations according to the sequence. Now, from first equation of motion, V equal to U plus AT. So we can write V minus U equal to AT when T comes this side, A comes this side, V minus U upon A is equal to T, or you can say T equal to V minus U by A. So now here, in place of T, we put the value of V minus U by A. So from 1 and 2, we can say V plus U by 2 into V minus U by A. Here, V plus U into V minus U equal to V square minus U square. As we know, A plus V into A minus V, A square minus V square. So here, V plus U, V minus U, V square minus U square, 2 into A, 2A. When 2A comes this side, so 2S equal to V minus U square. So V minus U square is equal to 2AS. This is the third equation of motion. So we have discussed all the three equations of motions, derivation of all three equations of motion by graphical method, and we can go in brief. So in case of first equation of motion, simply we split V as U plus BD. In this way, we find BD as AT, so U plus AT. So in the second equation of motion, so this is the first equation of motion. We can write in your notebook by pausing the video. Now, this is second equation of motion. In the second equation of motion, we find the area and we split the area in two parts: area of triangle and area of rectangle. Area of rectangle UT, area of triangle half AT square. So UT plus half AT square. This is the second equation of motion. In case of third equation of motion, again first we find the area of this figure, but we apply the formula for trapezium: 1/2 into sum of parallel sides BC plus OA, B plus U into height T, and we find the value of T from first equation of motion as V minus U by A, and we put the value of T from here, V minus U by A, so V plus U into V minus U, V square minus U square, 2 into 2A, so S equal to V square minus U square upon 2A, so 2S equal to V square minus U square, this way V square minus U square equal to 2S. This is the third equation of motion.